Yeah.
All right. I am ready.
All right. Hi, my name is Anya, and this is
Bill.
And we are here at St. Benedict Prep on the third floor in Sister Fran's room.
Our purpose is to show that the formulas are related and in turn are related to this roller coaster. The students have done independent research and they have science for their formulas. We're also going to find out how the formulas are related to each other.
Great.
Start off with Connor.
Seemingly, density equals mass of volume, which it represents roller coaster in a little way, but we want to show that it has a relationship between each other. Density is the amount in a certain object. To begin this project, I would like to hand this over to Adolfo.
This is S over D over T, which that means speed equals distance over time. As you can see here, we're gonna use speed equals distance over time in the beginning, and then as the time it takes for it to go down and the distance, we'll divide it, and then that'll give us the speed of how fast it's going. I'll give it to Lamont to explain the other part.
This is V equals D over T. Velocity equals density over time. It's almost the same as this, but it's speed and direction. As you see right here, this has a lot of direction as it's shown around the roller coaster. I like to pass this to Eric.
A as an acceleration basically equals the initial velocity, v1, subtracted by the final velocity, vf, divided by t, time. Now, it may be hard to get a definite acceleration with all these loops and curves and slides, unless you take it segment by segment.
My formula is P equals m times v, or momentum equals mass times velocity. The point of velocity is to explain example for a big, large marble and a small marble. They may obtain the same velocity but have the different mass, which will determine what with momentum would equal up to.
F energy equals m times a. Energy equals mass times acceleration. As you can see right here, if you put the marble, you're gonna have a lot of force going to the down slide, and then the mass of the ball and of the curves and everything, and the acceleration too. F net is basically like all the energy, well not energy, but all the force, the force that's coming down the ball, well the marble going towards down, and then the ball is F equals G M1 and 2 over D2 over force equals gravity masses over density squared. What the force is giving it to the ball is going towards down. The gravity is holding the force pulling the ball. Yeah, it's pulling the ball inside, and the mass is two. If we got two balls, like first ball comes down, and then the second ball comes down, and that's like one towards the gravity to hold the ball. Now those two.
Alright, so I had G equals N over kg. So G is the universal law of gravity, and N is newtons or force. So, on a roller coaster, gravity is what pulls the marble down. So once you drop it, it's gonna go down no matter what. and N, which is newtons of force. The force pushes it so that it goes down faster. And I'd like to give it to Gustavo.
What I have is G equals 9.8 N over kg, which just basically means gravitational strength 9.8 newtons over kg. Like for example, like the world, well the earth, but it has a gravitational strength and plus has whenever an object goes to the Earth's area, which is the perimeter, the newtons and kg comes in because the Earth's gravitational strength is much stronger when it's connected to the object, so it goes down, not goes up to its gravitational pull. And for a roller coaster here, when the ball at the starting point, when it goes down, the gravitational strength goes down to all the loops and everything, and newtons and kg comes in. I have to pass to Alright, so what we have is Fg equals m and times g. The F is force, m is mass, and the g is gravitational strength. There's a G under the F because the force that we have is caused by the gravitational strength.
I have a question.
Sure.
What's the difference between mass and weight?
Mass is the volume and velocity of an object, and the weight is the mass and the gravitational force.
Thank you.
This reciprocal problem, as Hannah stated in the beginning, takes us back all through the formulas and repeats itself over and over.
Okay.
So that is the end of our presentation of the formulas that we have learned and how they relate to a roller coaster.
Great. Yeah, good.